The points A and B have position vector respectively. The line L has equation of this particular form. So this is vector equation of a line. Now I have to show that L does not intersect the line passing through A and B. Okay, so let's rewrite this in the form that we are comfortable. Vector equation of line L 1, negative 1, 3. You write in column vector, so it's easy for you to deal with it. 2, minus 3 and 4. Now let's find for vector equation of line AB. So how do? You know that R is equal to a point on the line plus lambda by its direction vector. So you can choose any point that you like. Now you have either A or B. It's up to you. I am choosing the A. And what is my B? My B is the direction vector or the parallel vector. How do you find the direction vector of AB? So you can either do A minus B or B minus A. Okay, so let's try. So how do I do that? I'm going to take my vector B minus my vector A. So if you're unsure, what am I doing with the AB? I'm doing OB minus OA, which will give me 1, minus 3 and 3. So you take that and then you park it here. Done. Okay. Now I need to show that they do not intersect. So your thought process is, what happens if they do intersect? If they intersect, it simply means, let's say you have vector equation of line L and then vector equation of line AB. Of course, this is in 3 dimension because it's a vector. If they intersect, what will be common for them? The common variable is going to be its x and the y and the z. So if it does not intersect, it is not going to be common. So my thought process tells me to compare the x of the, okay, see, where is the x? Okay, let's analyze that first. See, when you are writing R here, what is the meaning of this R? R simply stands for any arbitrary point. It means it could be x, y and z. So similarly, you are also getting an x, y and z here. It's any arbitrary point, the way you label the x, y and z. So let's do it for the first one. For the vector equation of line L. So if I were to do that, it's just a simple expansion. So I'm going to do x, y, z. How did I get this from here? Okay, now you open up. You go row by row. So how do you expand this? You're going to get 1 plus 2 mu. Then the next one is negative 1 minus 3 mu. And then the next one is 3 plus 4 mu. So they are the x and the y and the z like that. Okay, you go get that for vector equation of line AB. You can pause and try on your own. So I will be getting 1 plus lambda, 2 minus 3 lambda, minus 2 plus 3 lambda. At this point, I think I want to tell you that, look at this, I put a lambda here. If this is a lambda, this one is a mu. They can't be the same. You don't put the same constant value. If one of it is alpha, then the other one can be beta. Don't put lambda for both or don't put mu for both. Okay, all right. Okay, now we can start comparing. So you take the x from here, you compare with this. You take the y from here, you compare with this. Similarly with your z. I know they are not intersecting, but I want to approach as though they are intersecting. So for the x component, I will write 1 plus 2 mu equals to 1 plus lambda. For the y, minus 1 minus 3 mu. Okay, now what you're going to do, you're going to solve any two of it simultaneously and you go and find your mu and lambda. Once you got that, you put into the third equation that you have. Of course, student, what they will do, they will usually take the x and y and then they will try to solve simultaneously. But you are not restricted to it. You can do x, y, or you can even solve x and z simultaneously, or you can even do y and z, any one of it. So what I am choosing, I'm choosing x and y. Why? Because it's just there for me initially. So I'm just solving that. So I know my lambda here is equal to 2 mu. And this one is 3 minus 3 lambda equal to minus 3 mu. You can simplify further. You substitute your lambda. My mu is equal to 1. So what are we getting now? If my mu is equal to 1, therefore my lambda is going to be 2. So I got this. See, if they intersect, it simply means if I were to take my lambda and substitute here, and if I were to take my mu and substitute here, it has to be equal. The value that I get on my left hand side must be equal to the right hand side. But now because they do not intersect, it is not going to be the same. And that's how you prove it. Okay, let's try. So I'm going to take my z and I'm going to go for my left hand side, which is 3 plus 4 mu. What am I getting? I'm getting a 7 because my mu, by solving the other 2, here is 1. So I got a 7. How about my right hand side? Negative 2 plus 3. Your lambda is 2. So 6 minus 2 is 4. So you can just say 7 is not equal to 4. Therefore, they do not intersect. L does not intersect. The vector equation of line AB. Okay, now the next part of the question, they are asking me to find the position vector of the foot of the perpendicular from A to L. Okay, let's try to draw. Let's say if this is my L, what do I have on my L? You look at this. You have a point on the line L and you also have the direction vector. So in which direction is it moving? It's 2, minus 3 and 4 and I have a point on there. And you know that you can get the x and the y and the z coordinate by writing them row by row. Okay, so let's try. Similar to the previous one. 1 plus 2 mu minus 1 minus 3 mu. 3 plus 4 mu. What are these? These are the R. What is R? Arbitrary point X, Y and Z. I got a coordinate of any general point on my line L here. What does it mean? Okay, let's see if you are trying to figure out what is the name of this particular coordinate. You know it is going to be this whole thing. So how do you make it special? By cracking the mu value. It depends on your mu value there. Okay, so now let's try. What is the meaning of foot of the perpendicular from A? Maybe your A could be here and then when you join it 90 degree, there is a foot of perpendicular here. This is the foot of the perpendicular. Okay, so I'm just going to label it as P for foot of perpendicular. Now, can you tell me what is the general coordinate of P now? Coordinate of P. So can I take this and just write it here? Of course I can, because I'm not so sure of my mu value. The mu will give me the specific coordinate of a point on the vector equation of line L. Now I just need a general one. So I can just take that and copy. Of course I wrote there as a coordinate, but what I have here is in the form of a vector. So if you want to write it in coordinate, you just put a comma. Okay, so to make my life easy, I'm just going to write general position vector of P. Okay, and I'm going to just copy this and park it there. Okay, now let's move on. What do we want? So how do I find the mu value? If I can correct the mu value, then I'm done. But then how do I do this? I have a 90 degree over there. Now, you know that the dot product of two vectors is equals to the length of the vector itself multiplied with cos theta. But you know, if it is given that they are perpendicular now. Perpendicular simply means 90 degree. What is cos 90? Cos 90 is 0. 0 times by the magnitude it's going to give you a 0. So we call this as the scalar product being equal to 0. So anytime they are telling two vectors are perpendicular, then you can use this concept. Okay, now, in relation to this question, how will you find the vector A and vector B? So we're going to write this as the direction vector of your line L. And then for the B, you can take the direction vector of AP itself. So let's go and figure out, and you put this equal to 0. You don't write the position vector there, otherwise you will go wrong. I want the direction vector of both the line. So in which direction is it moving? Like this. In which direction? So the first one is this, easy. So to find the direction vector of point A to B, you can either go upward or downward. Right? It can be either AP or PA. You cannot take the position vector. You cannot just take this and try to substitute here. So position vector and direction vector, it's two different things. So let's try. So I'm going to put 2, minus 3, 4. What is this? This is the direction vector of line L. Okay, now how will you find the direction vector of AP? What is A? Position vector of A? It is given as 1, 2 and minus 2. Okay, let's put OA here. What is the position vector of P? We have just got it here just now. So let me just copy it again. Okay, now what will you do to find the direction vector? You can either do AP or PA. The sign doesn't matter. So I'm going to get 2 mu. So you take this and you minus this one now. Okay, so let's copy that here. Equate to 0. And how do you do dot product? You again go row by row, multiple, and then you sum them up. So I'm going to get 4 mu plus 9, 9 mu, 20, 16 mu equal to 0. That is 29 plus 29 mu. My mu is equal to minus 1. Okay, let's go back to the question. What do you want? You want the position vector of the foot of the perpendicular. So it simply means you want the OP itself. So what will you do? You take your mu value and then you substitute here. And that will give us with minus 1, a 2 and a minus 1. That's it. That is the position vector. You read here correctly. Are they asking for position vector or coordinate?